Hey guys, happy Monday. Alright, today we're going to be talking about how to multiply polynomials. So we covered how to add and subtract them. Now we're going to talk about how to multiply. And if you want to take notes on this as we go, I'm going to be in the textbook, page 472 and 473. We'll do a few examples. Feel free to pause the video as we're going through if you want to try some on your own to see if you understand. Alright, so let's get started. So to multiply, we're going to start off with just how to multiply a polynomial by a monomial, and then we'll build from there in the future. So the first example we're going to look at, right from the book, is negative 3x squared. That's a monomial, and we're multiplying that by a trinomial. 7x squared minus x plus 4. So we're going to go ahead and multiply this. Now there's a couple methods to use. I always use the horizontal method here because that's basically just, actually that is just using the distributive property. So you're going to take this 3x squared, go ahead and color code, 3x squared is going to get multiplied by 7x squared, or the negative 3x squared, and then we're going to distribute it to our next term and then our last term. Now to show what's going on here, and this step, as we get better with these, we're not going to have to show, but we're taking negative 3x squared, and we're multiplying that by the first term, 7x squared. We're taking negative 3x squared, and we're multiplying that by the next term, negative x. And then we're taking negative 3x squared, and we're multiplying that by our last term. Again, we're just distributing the negative 3x squared, so everything gets multiplied by negative 3x squared. So negative 3 times 7 is negative 21. Remember, when you multiply, you add the exponents here, same base. Negative 21, x to the 4th power. Then your next term, plus negative 3, the coefficient is negative 1 here, so your coefficient becomes a positive 3. X squared times x is x to the 3rd. So you're going to have positive 3x cubed. Then here you're going to end up with plus, well, negative 3 times 4 is negative 12. And then you just have x squared, because this is x to the 0th, really, there's no x that we see there. So we just keep it as x squared. We're going to clean this up a little bit. Negative 21x to the 4th, plus 3x to the 3rd, minus 12x squared. Here's our final answer, in simplest form and in standard form of a polynomial. So that's how we're going to show to multiply. You're just distributing this whole monomial to each individual term of the polynomial. Alright, let's go ahead and try an expression where we're going to incorporate this. We'll go on to the second example down here. We have 2p times the quantity of negative 4p squared plus 5p. So we're multiplying a binomial, or monomial by a binomial. And then we're subtracting 5 times the quantity, 2p squared plus 20. So again, we're going to do distributive property here. We're taking this monomial and we're multiplying it by every term inside. So 2p times negative 4p squared, I get negative 8p cubed. 2p times 5p should be plus 10p squared. Multiply your coefficients, add your exponents of 1, you get squared. Now here we're distributing a negative 5, so negative 5 times 2p squared should be negative 10p squared. And then we're going to have negative 5 times 20, and hopefully we get negative 100. And that would be, after everything has been distributed, now we need to combine like terms. So our p cubes, I only see negative 8p to the 3rd. P squareds, though, we have 2 of them, right here and here. And if we combine these, well, they end up canceling out, so they go away. We don't have them anymore. We have 0p squareds. And now we just have the minus 100 right on at the end. So right here, this would be our simplest form, and we're in standard form, going from greatest degree to least degree. And there we go. Just like that, we're all done. We're going to try one more, and then I'll tell you some things to look out for when you're doing these. So the last one, if you're still in the textbook, on 4th, 73, this is 2b, this question. And we're going to be multiplying 15t by 10y to the third t to the fifth plus 5y squared t. And then we are subtracting 2y times the quantity, yt squared plus 4y squared. So let's go ahead and distribute first. 15t times 10 y to the third t to the fifth. Well, 15 times 10 is 150. And then you're multiplying, well, let's see, like base, we have t to the first, t to the fifth, that's t to the sixth. There's no like base with the y, so y is just going to stay y cubed. And we're going to have t to the sixth, using our exponent laws there. 15 times 5, we should get 75. So 75, again, we can have y is going to stay the same, y squared, but our t to the first times t to the first, becomes t squared. Over here, we're multiplying a negative 2y, so we're going to have negative 2. We're going to end up with y times y is y squared. There's no base of t over here, so our t is just staying as t squared. And then we're going to have minus 8, negative 2 times 4, and then y to the third. So let's go ahead and look for like terms. Start with the highest degree. So we have 150, y to the third, t to the sixth. Nothing else has this as it, or no other terms are y to the third, t to the sixth. And we'll put that first. It's our highest degree. We're of degree 9 here. And then, let's see, like terms, y squared, t squared, y squared, t squared. These are like terms right here. So we're going to end up with 75 minus 2 is 73, y squared, t squareds. And then lastly, we have this, no like terms, minus 8y cubed. And there we go, we're in standard form, highest degree first, and then in decreasing order. And we're all done. Some things to keep in mind when doing these is keep an eye out for like terms, especially when you have more than one base like this, more than one variable involved, because sometimes it can get confusing. You have like a y squared, t to the third, so you have 4 of those, and then you have 3 y to the third, t squared. You really got to keep track of which is which. These are not like terms. They have to have every base, so every y squared, t to the third, you would need to have, let's say, plus 7, y squared, t to the third. Your base to the exponent has to be the same and consistent for them to be like terms. These would be like terms. So be really careful with those and just make sure your final answer is in standard form. Combine all your like terms. Underline if you need to so you don't forget anything and you don't double count anything. And that's how we can use multiplying monomials into polynomials and then just simplify like we have done in the past. Alright guys, that's all for today. Have a nice day and enjoy.